Welcome to the video on simplifying radicals. So we have a few things that we're going to cover on how to simplify radicals. And the first thing is all about finding perfect squares that divide into a radical. And that means that you can simplify it. So if a perfect square is a factor of the radicand, then it can be simplified. So here we have our radicand, the 8, and we need to figure out, can a perfect square go in there evenly? If it can, then it's a factor. So the first thing we need is our first 9 perfect squares. Now, hopefully, eventually these will be in your head, but it's nice to always have a little list nearby that you can test with. I think this one's pretty easy to figure out what goes in there, but let's make a list of the first 9 perfect squares over here. Okay, so pause the video and come up with the first 9, and then rejoin me once you think you have them and check with mine. Okay, here they are. 1 is also a perfect square, but it actually doesn't change anything if you divide it by 1, so we're going to use these. If you have these, you can do these steps here. All right, so factor the radicand using the largest perfect square and break it into 2 radicals. So from our list, we're going to figure out which one of these goes in evenly, and we prefer to find the largest one. And I'll show you how, even if you don't find the largest one, not all is not lost. You can still figure this out. But with 8, it's pretty easy. 4 has to be the largest one, and then break into 2 radicals. Well, we know that we can multiply together radicals to equal the number, so we just multiply together the radicands, therefore we can just factor it out like this. The square root of 4 times the square root of 2 equals the square root of 8. Okay, so we've done this one, we've done this one. Simplify the perfect square radical. So once you pull out a perfect square, well, we can just find the square root of this. This would just be 2. And then you leave the other one inside. Multiply any coefficient, the number in front of the radical. So we don't have that going on here. We do not have a number out front here, so this is just 1. And if we do 1 times 2, we would still end up with 2. So this one's fully simplified. And add these notes in here, but you want to always have the whole number first and the radical second. All right, so let's do this again. If a perfect square is a factor of the radicand, then it can be simplified. So are there any perfect squares that go into 32? There are. Now we prefer to use the largest. So I know that 4 goes in there. I also happen to know that 16 goes in there. So I'm going to choose 16. If you choose 4, you could still simplify it to the end, and I'll show you how to do that in this next problem. But let's go with 16 since we know that that's the largest. So 3 is going to stay out front times 16 times 2. Right? So if I were to multiply all these back together, I would end up with 3 root 32. Now I'm just going to take the square root of 16, which is 4. So I have 3 times 4 times root 2. 3 times 4 is 12. Times root 2, you can just drop that multiplication symbol in the middle there because when you put them next to each other, that implies that they're being multiplied. So we have 12 times square root 2 is the simplified form of 3 root 32. If you were to take out your calculator, multiply these together, and multiply these together, you should have the same answer. Okay, so we're going to do one more together, and I'd like you to pause the video and give this one a try, and then rejoin me once you have figured this one out, and I'll go over it. Okay, so you've at this point done this problem, and now I'm going to show you how to come up with the answer. So we need the largest perfect square, and some of you might have realized that that's 100, but I want to show you that even if you don't always come up with the largest, you can still figure this out, and that has to do with this last step here. So I'm going to go with 25 instead. So if I break this apart, I would have 25, the square root of 25, times the square root of 8. So still the same steps so far. Simplify the perfect square. So this would be 5 root 8. Multiply by any coefficient. There's not one out there, or it's just 1. So 1 times 5 is still 5. And then our last step says check that there are no more factors of the radicand that are perfect squares. So if we look back at our other ones, 2 is not divisible by any of these numbers. Right? So we were fully simplified. However, 8 is divisible by one of these numbers. So all that means is you haven't fully simplified it. So if you get to the end and there's still a perfect square in there, keep going until there is not. So 8 can be broken up into square root of 4 times the square root of 2. I find the square root of 4, and that's 2. So I have 5 times 2 times square root 2. And 5 times 2 is 10, root 2. So even though I took a longer route, I still got there. It would have been a little bit faster. Let me show you another way that you could have figured this out. It would have been a little bit faster if you saw right away that 100 is a perfect square. So we have the square root of 100 times the square root of 2, and then this would just simplify to 10 root 2. So we get there either way. And if you use the larger perfect square, you get there faster. But if you use a smaller perfect square, it doesn't mean that you won't get there, as long as you do that last check at the end to make sure. Now, if I was taking a test, I would go ahead and use my calculator and multiply 10 times the square root of 2 and make sure that I ended up with the same thing to check my work there. All right, rationalizing the denominator. So there's a rule when you're working with radicals, and that is that we do not leave radicals in the denominator, no radicals in the denominator. So the way we do that is what we call rationalizing the denominator. So you can see on both of these problems, I do have a radical in the denominator. It looks like I have a negative there, which I didn't really mean to do, but since it's there, let's just discuss how we would handle that. So a negative, whether it's in the denominator or in the numerator, just makes the whole number negative. So our final answer is just going to be negative. It doesn't matter that it's on the bottom or the top. It also shouldn't affect how you rationalize the denominator. When we come up with these simplified forms, they're equivalent, they're the same. They just look different, right? But they should have the same value. So if you have a negative fraction at the beginning, you should have a negative fraction at the end. So I'm just going to put the negative there. And I'm going to do my work down here so I have more room. All right, so what we're going to do here, well, let's go over something really quick here. If I have the square root of 2, and I multiply it times the square root of 2, I end up with the square root of 4, which would then give me 2, right? So what we can see here is if you take a radical and multiply it by itself, that undoes the radical, and then you just get the 2 out. So if I take the square root of 3 and I don't want a radical above it, well, I can just multiply by the square root of 3. Okay, but notice that I made a fraction here because I don't want to actually change this number. If I were to multiply this number by 1 over the square root of 3, I wouldn't have the same number. So what I want to do is multiply my original number by 1. If I multiply anything by 1, it keeps it the same. So coming over here, what would I need to put on top to make this fraction be the same as 1? Well, if the top and the bottom are the same, that's 1, just like that. So now when I multiply across, 1 times square root 3 is root 3. And then root 3 times root 3, well, that's just going to undo the radical. If you'd like to show the step in between, if that helps you, then just do square root 9 and then keep going. The top cannot be simplified. It's just root 3. The bottom can be simplified. It's 3. And then be sure you don't divide those, right? Because you can't divide a radical by a non-radical. All right, so here's my answer. And remember, it was negative at the beginning, so I'm going to put it up here next to this negative sign. It's a little squished in there. And there we go. Okay, one more here. Go ahead and pause the video and try to figure it out, and then rejoin me. Okay, so what I didn't tell you before you paused, and I'm going to tell you now, is that you only need to multiply by the radical. And it doesn't mean that you're going to get a wrong answer if you multiply by the 2 root 3. It's just going to make it a little bit longer. And I was okay with you doing that so you can hopefully see that you'll end up with the same answer. But it is preferred to just multiply the top and bottom by the radical on the bottom. So let's make a little note about that down here. So multiply the top and the bottom of the fraction by only the radical on the bottom. Okay, so if you did it the other way, see if you still came up with the same answer here. So I'm going to multiply by square root 3 on the top and on the bottom. And I multiply across, which gives me 5 root 18 and 2 root 9. And now at this point you could divide there, or you could also just go 5 root 18. And then the square root of 9 is 3, and 2 times 3 is 6. Okay, so always check your radicals at the end. You should not have a radical in the denominator, and you should not have any perfect squares that divide into the radicals that you have. So for instance, 18 is divisible by, look up at our list again. Well, it's always nice to have that little list in front of you to check, but it's divisible by 9. So this is now going to become, I'll move it down here. So 5 times the square root of 9 times the square root of 2, all over 6. Square root of 9 is 3, so 5 times 3 is 15. Move my little words over here. 15 root 2 all over 6. 3 goes into both the top and bottom here. So I'm going to keep going with this. We want these fully simplified because 3 can go into here 5 times. And 3 can go into here 2 times. And finally, 5 root 2 over 2. There we go. Let me show you an alternative way that we could have figured this out up here. Right at this point, if we just, that is an arrow, not a smiley face. There we go. If we just divide the 9 into the 18, we would have right there ended up with root 2 over 2. Right? So both ways, we end up with the same answer. Okay, that was a tricky one. If you got all the way to the end and fully simplified it, you should definitely give yourself a pat on the back. If you didn't, don't worry about it. We're going to work on this. And hopefully by the end of practicing this, you'll be able to get from here to here successfully. All right, that is the whole video. Thanks for watching, and I will see you in class.